guys, my name is Manny and I'm back with another video. This is actually my first official video in this channel where I'll be tutoring or giving like some explanations on the topic for the task of the day. I'll try my best to post every day a short summary of the content so you do not have to go through the resources and study everything. I mean, you can still do that if you want to like understand it yourself completely in depth, but I'll be covering the essentials and everything that you will need in order for you to successfully answer the tasks with understanding, so that you don't have to copy and paste. Yeah, so before we start, welcome to my channel. It's new, so my subscriber count is quite low. That's why I really encourage you to please do subscribe and put on your notification bell, because I will be posting every single day. So yeah, and I would also like to ask if it's possible, if it does not disturb you, if you can just share the video inside your WhatsApp groups, inside your Slack groups, so that I can get more exposure and more people can understand, and there'll be more graduates this year. So without any more delay, we're going to start with C programming language. We've been doing shell and all the other topics which were not really programming languages. This is the first topic or the first programming language that we're going to learn. So it is C. Yeah, so I've studied this before at university, so I do have background on C. I do have quite a good understanding on C, so hopefully I will be able to explain it well enough for everyone to understand. So like, yeah, let's start. So cool. Normally they would give us the name of the repository that we're going to have, so I just made mine ALX tutor. So obviously when you're gonna create the repository directory, you're gonna use the name that's gonna be asked. So for this one, I just made ALX tutor, so I'm gonna cd into that ALX_tutor, and then if I ls, it's empty. So normally they'll also give us the name for the directory in which you're going to work in. So I'm just going to write mine as hello world. So I'm just going to make mine hello world. So before we start, in order for our checkers to work, because if we do not do this next step, our checkers will always never work. You will always get an error for everything because this is not done. So the first thing that we need to do is firstly create a readme file inside your working directory or your repository, which is the ALX tutor. So we need to create a readme file, which is important. Without the readme files, you will always have errors. So we'll do that. So the readme file has to be non-empty. That means there has to be some form of content. It's not specific. You don't have to write something specific. You can write whatever as long as it's not empty. So I will just write hello world, and then I would say I want it to be in readme. So I have now hello world, the working repository, and the readme file, which is not empty, inside my repository. And then I'm going to cd into hello world. If you press tab, then it auto fills the directory. So now I'm in hello world. If I ls, it's empty. So I'm going to create a readme file in here as well. So echo, let's just write hello world again, but you can write whatever you want. Then readme. So So this should become second nature whenever you're doing a task. Okay, so once we've done about putting in the readme files, then the next step we do is to create a C file. So a C file has to end with .c. So this is very important in order for our compiler, which is something I'll touch just now, to identify what type of file it is. So when I want to create a file in which I'll be writing my C code in, I must make sure it ends with .c. So since we're busy with hello world, I will touch a new file which I'll call it hello.c. So that is the new file. So if I ls, I'll have my readme file and the hello.c file. So now the hello.c file is where I'll be writing all my code. So depending on the task, I'll be writing everything inside this file. The same way we used to write scripts, we will be writing this hello.c file inside this hello.c file and make it executable by compiling it, and then we'll work with that. So if I have to now enter the hello.c file, as we know, we have worked with VI or Vim before. I'll press I for inserting. So there are certain things that you have to take note. When I learned C, we used to use IDEs, which is like an environment where we can write code and it used to compile by itself and then you get the output. But now with the ALX, we're going to do everything inside the Vim or VI. For those who prefer Emacs as well, you can do that in Emacs as well. But majority of us will probably do it in VI. So there are certain rules. So ALX has adopted the Betty system, where there's a certain guidelines or certain way that they want us to write the code. So if we do not write the code that specific way, then we're going to get errors. So we need to know what is the requirements for Betty. So I'll make a different video on that, on how to get Betty installed inside your terminal and what is the rules and everything on that. So I'll make a separate video on that. So if you're interested, you can check that out when I release it. So I'm gonna write the first code for the hello world, how to print out hello world in C. So we can do that. The first thing that we need to do, that we need to include, is the header files. So these are things that you will need to know, and it has to become second nature when writing a C file. So it's #include standard SDIIO, meaning it's a header file or a library in which all our input and output commands are stored. So we have to include this in order for the commands that we'll be putting in to work, so that our computer know what it is. So for example, our printfs and our put chars and all our puts and gets and all other input and outputs, they're all stored in SDDIO in order for them to work. So we're gonna put that in, and then we're gonna leave one space open, and then we're gonna put our comments. So this is very important. Your comment has to be there, which explains what your code is gonna do. So it is to make sure that if anybody comes and check out your code, they will know exactly what your code is doing. At least like a small overview on what is the code. And the comments, we put it inside like this. So we put a / and then a star. So now it's what everything that's going to be following after this is going to be comments. So I'm going to make that, and then I'll write So if you want a new line, you just put that and then you say main. So this is the entry point. Oh, sorry. I mean, are you really a programmer if you don't make typing errors? So I'll do that. Then return, we have to write what type of return you'll be getting. So our return in C will always be 0. So you'll see when I write the code what I mean by we have to specify what you're returning, and it's always going to be 0 in order for it to be successful. So if you write return 0, that means you're saying your code is successful. So these comments, you can actually write any comment depending on what type of code you're going to write. So I'm just writing this and then space, and then now I'm going to have a main file. So I'm going to write int main. This is the syntax for C. Void, meaning the parameters that I'm taking is a void. So I'm gonna put curly brace. So everything that will be inside the curly brace is the code. So the main is basically the body of the code. So if I want to write a print statement, a code that prints out a specific word, so I would write printf. There are a lot of variables that we'll learn, a lot of inputs and output variables that we'll learn. Printf is basically a command in which it will print out whatever text or whatever I write inside the printf. So it has to be inside the quotation marks if it's what text, if it's strings. So if I'm gonna say hello world. So it's going to be printing out hello world, and then one thing, you always have to write your semicolon. So it's basically to say I end this line, this statement or this command ends here. So without that, your code will fail. You will get a compiling error. So you always have to remember your semicolons. A lot of programmers, they wrote long codes and then they received errors and then they didn't know what was wrong, and then they only to find out that the problem was just that they forgot to put a semicolon. So you should really make it a must to include your semicolons, otherwise your code will not work. So if your code don't work, always check, okay, did I write my semicolon? And also to make a new line so that when it prints out hello world, whatever comes afterward will be printed on a new line. We write / or backslash n, which basically means new line. So \n, so it's a new line, and then after that you have to write return 0, which will indicate that you are done. So return 0, and then remember your semicolon. So that is basically a simple code on how to print hello world. So I will exit, I'll save it and exit. And also to check if you have Betty already installed, which is going to be in the next video, because Betty is a system in which ALX adopts in order for them to keep a certain standard of code. So to check if you have Betty, or to check if your code is Betty approved, so if Betty were accepted, you will write Betty hello.c. So okay, so here they give me an error. So that means Betty did not accept my code. That means I did something wrong. I did something that was outside the guideline. So they say in line 11 there's an error. there's a space required before the open parentheses. So let me go back into my code. Let's say in line 11, I need a space before the open parentheses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So which one is that? I think it is here. Yeah, I need the space here. Yeah, I think that is it. Let me go back. So that's how you check if there's any errors in your code. You would ask Betty, say Betty, is my code okay? Please Betty, accept this code. So okay, there's no errors, it just like main, meaning my code has been approved by Betty, there's no error. I followed the guidelines. So that's how to check if your code is Betty approved. So that was a simple hello world statement where I just print hello world. Now in order for me to compile it and to run the code, I will have to use something called GCC, which is the way in which we compile. So to compile, the term compile basically means I'm taking the human readable code that I just wrote, the printf statement, and I'm going to convert it into machine code, or machine executable code for the computer to run it. So it's basically saying, it's basically a translator. It's translating my English code into a code that the computer can understand. So computers basically understand zeros and ones. So it's basically a process in which it converts my code into zeros and ones. It's a 4-step process which I will touch also in this video. So to also check what type of compiler you have, you can write GCC version. They need to tell you what type you have. So we have a GCC 0.2, 9.4, blah 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 blah. So it's to tell me what type of compiler I have. So now to compile my code, I basically write GCC hello.c. So it has what? No such file directory. Include stdio. Okay, so I had an error. But Betty, why didn't you tell me? So Betty just told me based on my syntax. And this one is an error, my hash include. So I made a mistake somewhere there. Yes, I made a mistake. So let's go back to my code. I made a mistake. Okay, so let's go back here on top. So it's a header file. So I have to write .h. So that's very important. So it's standard input output .h to specify that it's a header file where all my header files are stored. So it's a library for header files, and it has to finish with the .h. So that was the problem. So let me just clear that out, and then I would write GCC hello.c, and then my code is compiled. So after it is compiled, I can ls, and then I'll see hello.c, and then also a.out. So that is basically my executable file. So it has converted my hello.c into a .out, basically meaning something that's executable. Like it's equivalent to the chmod. I don't know if that's how it's pronounced. So it's making it executable. So basically, if I want to execute this, I would just write back / a dot out, and then out it would write hello world. So now it ran my code, which was a print statement, where we just wrote hello world. So that is basically how you would write a C program in VI on your terminal, and then how you would compile it using GCC, and then if you want to run it, or to run it, then it is dot / or / a dot out, and then it will give out the output. So the next step is, what is compilation? So what is the process of compilation? So let me take out something so that I can also explain. So basically, compilation is the translation of source code into object code by a compiler. So there's 4 ways in which a code is compiled. The first step is the preprocessor. That step is when you take the header files and other tasks necessary for the code to compile. So there's a lot of background things that takes place, like the header file, the one that we include the first line of the code, which is the standard input output.h. So in that library, that's where all the commands for the header files are stored, which is basically our printf statement that we just use. There's the scanf, there's the puts, there's all those commands and more that are stored in the header files. So the first step, the preprocessor, basically run those files first, and then after the first step, the preprocessor, we have the compiling phase. So the preprocessor, which we will cover, I guess, in the first few the questions for our task, is when you use GCC -e hello.c. So it basically, when we did the GCC hello.c without this and this, it basically just compiled it, and then it converted it to the a.out file. So this is basically that, where it converts it from where it converts the .c into a .o, into an output file. So that's the first part, and then the second part is the compiling. The compiling part is when it takes the assembly language, which is the low-level language. So after it goes from the preprocessor, it is being translated into assembly language, which is basically another low-level language for the computer to understand. So it compiles that, and then it makes it an executable file. So that is the second step, takes it from a .c file to a .o file, which is basically from a normal file into a executable file. So after it goes from the compiling phase, it goes to the assembly. So the assembly takes the assembly code that was converted to machine code. It now converts it to binary code, which is basically zeros and ones. So the compiling file is where we now compile the assembly language. But now the third step is the assembly language into binary language, which is basically zeros and ones. So at this stage, our code that we wrote is now just zeros and ones, so that the computer can understand it. And then the fourth step, which is basically the linking phase, which is it takes all the compiled files and all the stuff that we outputted from the first 3 steps, and then it links it together and combines it with the library files to make a executable file. So that's the 4 steps of compilation. So the compiler we'll be using as an example is GCC, which stands for GNU Compiler Collection. So we really don't have to go into much detail on that. But if you want to, you can always research that and see more about the compiler. So yeah, that is just that. That's about the compilation part. So now we can go back to our code. So from what we've learned, we can take our .c file and convert it to a .a file. But then this step is not really efficient, if I have to say. It's not really like we can do it in one command instead of having to first go GCC and then afterwards then we have to do this step. So what we can do, or what we actually gonna be doing, is writing GCC hello.c. So we're gonna say I want to send it into I want it to become a .o file, a .out file, or an executable file. So I'm taking my GCC hello.c, I'm converting it or compiling it and making it a executable file, which is -0, and then I'm gonna say I want to save it into hello.o. So hello.o. So yeah, so now I can now do that. So now this step, I can skip this step. So if I write ls, then I will have my hello.o here, and this is from the other step. So if I have to run this, then I can then to print out the output of my code. So I can do this hello.o, and it will print out hello world. So this is basically the command it will be doing. So I took my file, I compiled it, made it a .o file, an executable file, and then I stored it into hello.o. So now whenever I want to run my code, I would just run the hello.o file. So yeah, that is basically that for the C tutorial. I want to do some examples. You can do some examples which are basically the same as examples that we'll be doing into today's task. So I basically just change it up a bit so that it does not, it's basically the same. I just changed the name. I couldn't really change much. So we're gonna do this question. The first question is a preprocessor part. So this you'll become familiar when you receive the task, and then you will see that I just basically changed the name here and then change this name, but the question is exactly the same as the task. So we're gonna answer it together, and then I think that will be the end of the video. So the first question they ask us is, write a script that runs a C file through the preprocessor and save the result into another file. The C file name will be saved into the variable my file, and the output should be saved in the file C file. So basically we can do that. As we all know, the first step is to create a file called let's just write 0 preprocessor. So the name will be depending on the name that they want us to have. So I'm just going to write 0 preprocessor. So that is my file which I'll be storing, and then I'll go inside that file. So I would go into that file to answer the question, and then press I, and then they ask us to write a script. So we all know to write the script is a standard. There's something that always has to be included, which is the hash !/ /bin/bash, which is always a must for a script in bash. And then one of the requirements in our task is always that we use 2 lines. So they want us to write the code that runs our C file through the preprocessor and save the result into another file. So this is basically the first step of compilation. So the first step of compilation is GCC/E. So that is the preprocessor part. So whenever you hear preprocessor, then you remember it's GCC-E and then the name of the file. So the C file will be saved inside the variable. The variable that they asked was my file. So that's where we'll be saving it. So let me how to do this. Okay, so I would say they want us to save in my file, which will be that my file, and then they want us to output it into another file, and then the other file that they're speaking about, they say want us to output it into another file, and the output should be in the file C/file. So we want our output to be an executable file, so it's going to be -o is an executable file, and then the name of the file that we want to store it in is the C_file. So this is basically the answer. So for today's task, the name will just be different and the file that you save it in will be different. I think it would just be C, and this will be C file. So I just changed the name just to make it not feel like we're gonna copy and paste. So that's it. Then I would escape, and then that's that, and then I can make it a script u plus x, and then preprocessor. So that's that. So I won't really add it and commit and then push because the checker won't work because I'm doing it in my own repository. So the next question is basically write the script that compiles a C file but does not link. So they want us to create a C file that just compiles it but does not link, meaning it does not save it into another file. So I'll create that file for this question. I'll just write /compiler. So basically all this question will be very similar, just the naming will be different to the task of today. So let me VI into that. Okay. So we have to include this. Then bash, and then the answer. So they want us to write the script that compiles a C file but does not link it. The C file name will be saved into the variable my file. The output should be named the same as the C file, but with the extension .0 instead of .c. An example, if the C file is main.c, the output should be main.0. So basically we want us to compile it without sending it into another file. So it should be the same the same name as the .c file. So in the previous example we saved it into the C_file, but this one they don't want us to save it into another file, but they want us to compile it and then keep the same name. So to do that we can just write our normal GCC and then C. So we want take the C file, compile it, and then save it into the same name, which is my file. So this will basically do what they want us to do. So normally we would write that and then C file to save it into the C file, but they want us to keep the same name, my file. So in order for us to do that, we will remove this part. So this will just compile it and then make it into a my file.o. So we escape. So you'll do the same thing, you'll make it executable. So that's that. And then the third question, the assembler. So they want us to write a script that generates the assembly code of a C code and save it into an output file. And the requirement is the C file name will be saved into the variable my file. Okay, and then the output file should be the same name as the C file, but with the extension of .c instead of extension file .s instead of .c. So to do that, the first step is to create the file in which we'll be writing our code. So it will be 2.assembler vi. Remember, these questions are basically the same as the task. I just changed the name. So this is basically the answers for the task. Standard I think it's called Chapang. Okay, and then the answer. So they basically want us to convert it from a .s file to a .c file, and the C name will be saved in the variable my file. So I'll say gcc/s my file, and then that's basically that, because they want us to keep the same name. So we won't be writing the ./out into another variable. We'll just be saving it into the same name, so we don't have to output it into another file. So this gcc.s, we know the gcc is to convert or to compile our code. So we will be compiling it. It's a .s file. We'll be compiling it, and then we'll be saving it into the variable my file. So it will convert the my file.s, which is inside here. So if we had to check the content of my file, it would have a file called my file.s. So it takes that my file.s and converts it into a .o file. So that's basically all. So I will escape, and then I can do that. So I would say, so I exit, and then I would make it executable again. Okay, so that's that. And then now the last question. Write a script that compiles a C file and creates an executable name called ALX, and then the C file will be saved in the variable my file. So they're telling us that we must write a script that converts the C file that is stored in my file, which will be something myfile.a, so myfile.c. Yeah, it will be a myfile.c that will be stored in here, and then they want us to create a script that compiles it and makes it an executable file, and then we want it to be called ALX.c. So let's first create the file, and I'll write 3, and then let's make it, okay, let's just give the same name as the task, so it should be name, and then that's that, another vi 3 name, and then I'll write my shebang. Okay, and then the answer, so they want us to create a script that compiles a C file and creates an executable file. So we know to compile, we use GCC, and then it's a C file, so I'll say ./C. No, it's really a C file, so I don't have to write the -C because they already told me that it's a C file that is stored inside my file. So I'll just write my file, and then I want it to be an executable file, so it's /0 inside the file I like C, so like I_like_C, and then that's basically the code. So it takes the .c file that is stored in my file, it compiles it, and then it converts it into a .o file and saves it into ILike.c. So that is basically that, and then I escape, and in that I make it executable, and then so if you have to check the code for all of those steps, you should be getting no errors. So that is that, and then there's one question that I want us to do. There's one question that I want us to do, which is basically my example that I did. So let me get that question quickly. So write a C program that prints exactly with proper grammar. So they want us to write the print this statement here in full screen first. The statement followed by a new line using the function printf. You're not allowed to use the function puts. Your program should return 0. Your program should compile without a warning when using the raw GCC option. So to answer this question, we write a program that prints out with proper grammar, but the outcome is a piece of art. So they want us to write a print statement that prints out this, and they want us to follow it by a new line. So let's answer that question, and then I guess will be the end of the video. Okay, so here inside hello world, I will write the file. So let me just call that let me say printf. Yeah, printf, and then I vi into 4. So this is no longer a script. So like I did the first time to write a C file, a C program, we're gonna need to include #include standard input output.h. So this is something that has to be included always, and then our comments explaining the code. This also is a must. So it's a main. It's gonna return 0. They even specified here your program should return 0. So in my comment, my description, I will write that it returns a earlier program if you don't like typing errors. Return always. I want problems. Return always 0 to indicate success. And then that's the end of my comment section. And then space my int main. So it's inside your main where your compiler will be reading. So whenever you compile something, your compiler always look for your main. So whatever will be written inside your main is what will be compiled and outputted. So your main is what will be compiled, it's what will be executed. So without the syntax, what am I doing? Okay, curly braces. Okay, so they want us to write a print statement that using printf, use a function printf that prints with a proper grammar, but the outcome is a piece of art followed by a new line. So I would say printf since it's string, we need to put them in quotation marks, quotation. So I can just copy and paste that. So let me copy and paste it. Whoa. Okay. Copy that and paste that. Okay. So it should return 0. So okay. Full screen there. So they want also to be followed by a new line, and another command for a new line /n. So it will be that. So this is basically the question or the answer for the question. And then you always remember your semicolon. Without that, it will not run. Then they want us to return 0. Return 0 and then your semicolon. So this is basically the answer for that question. So I can escape. So let me check if it's Betty approved. Auntie Betty approves of it. Let's write / what are you saying? Yes, there's no problems. Auntie Betty approves. So then I can now compile it. Compile GCC. hello.c /hello -0, and then I want to save it inside hello.out. So that is basically how I compile it, and then that's that. There's no errors, so it compiled correctly. So now to check if my code outputs the correct output, which is yes, hello world. No, it should not be hello world. Why did I compile hello world? Okay. Okay, sorry guys. It should be GCC 4/printf. I just made a couple of mistakes. Let me just correct the first mistake that I did. Very rookie mistake. Let me just rename. Let me see. Where is it? 4.printf. It should be 4.printf.c. So that should be the first one that I do. So it should be 4.printf. So it should be 4.printf.c. So remember that it should. I was so used to answering the questions that I forgot that I had to make a C program. That's why I did not include the .c. But you should always include the .c. That's why now I'm renaming it to .c. So now you will see that it's now called the .c. Then I can compile it. So let me just clear that and then go back. And then I would now compile that. So /.c. I'll save it in for printf.out. So it is compiled. So if I have to ls, the compiled file is here, the executable file. So now to see if I made no mistakes, printf.out with proper grammar, but the outcome is a piece of code. So that is basically that. So that is, I guess, the end of my video. It's longer than I expected. It's around 50 minutes. So yeah. Cheers. I hope you liked it. I hope you enjoyed it. I hope it was useful. And I believe it was useful. It basically answered everything. So if it was useful, please do like, do subscribe, do share it with many. And then yeah, I'll see you in the next video. Probably the Betty video or the video for tomorrow's tasks. Yeah, peace.